Now we're ready to calculate the standard deviation for a population. Copy the data down again for Group A and Group B. And remember, the question was, how much money do you have on you? Or this is the program that we're using. It's called a spreadsheet. And this one is called Excel. And you might use SCalc, which is in OpenOffice. I've highlighted the median value for each of these. And I've also shown here the mean, but I'm going to show you a way of calculating the mean using Excel. So it's a formula. Formulas always start with an equal sign. In this case we use the synonym average, and I always have a bracket with these functions, and I open up the parentheses, and it wants now to know what numbers do I want to average. So you take your mouse and you grab the numbers you want to average. And it's entered it for me, C5 through to C11. So C is column C, 5 is row 5, all the way through to row 11. Close your bracket and press enter. So that's the mean. Now that I have the mean, I want to calculate how far each of my data values are away from the mean. That tells me how variable it is. So I'm going to write down equal sign because it is a formula. My number, take away the average. So I'm going to put my minus sign, click on the average, and press enter. And it is 3 away. Not only is it 3 away from the mean, but it's 3 below the mean. I just want to caution you here. The mean always stays in C12, and we show that in Excel using $sign. So $C, $12 means when I copy the formula, change the rows, but don't change the mean. Okay, here we go. So I'm going to click on my formula I just copied. I'm going to grab the copy handle and drag down. And it's calculated deviation from the mean for each data point. So if I click on the last one, for instance, and go up to the formula bar up here, you can see that it says equals C11 take away $C, $12. So the row number that originally started out with as 5 has changed to row 11, and the mean, which is stored in C12, doesn't change. So that's what the $signs do. The next is calculate the square of the deviation. It's multiplication by itself, -3, which is stored in D5. The operator for times is the star, and then click on D5 again and press enter. Notice there are no $signs because each row value should change as I copy the formula down. So I press enter. Confirm -3 times -3 is +9. I'm going to click on +9 and copy it down. So there is the square of the deviation. So I'm going to quickly do this for Group B equals its data point, take away its average. Notice it's column H, $H, $12. -2 is also below the mean of 5. It is 3 below. And I'll copy this down. That gives the deviation from the mean for each data point. We're going to square it. -3 squared is +9. Just a random check. 2 squared, 2 times 2 is 4. There we go. Now we have calculated for each data point how far it is from the mean, and then we squared it to make sure that numbers that are far away affect the standard deviation more, and it should. We want to find the average of the square of the deviations. So we totaled this, and we use the auto sum feature, which is on your menu bar. It's the sigma symbol. I click on it. It assumes that I want to sum or average these numbers, which is correct. I press enter. So all of this adds up to 20. That's the square of the deviations. I'll do the same thing for Group B. I'll use the auto sum feature and press enter. So the square of the deviations for B is 34, whereas the square of the deviations for A is 20. To find the average, so that equals average of these numbers, and that's 2.857. So 20 divided by the 7 people, or 7 pieces of data, gives me almost 3. Just wanted to show that. and I'm going to find the average of the groups of the deviations. So average of these numbers. Notice it's not the average of the data, but average of the square of the deviation. And it's 4.857, or 34 divided by 7 is about 5. So these two values for each of the groups is called the variance. That is not the standard deviation. We've got one more step. Now we have to square root it to get a more sensible number. So I use my formula, square root equals SQRT bracket square root of this number here, and press enter. And the square root of the variance here is 1.69. We call that the standard deviation. Let's do that for B. To save yourself some work, I can take this formula and copy it. Control C and Control V. And it's 2.2. Okay, notice that it does adjust automatically for you. If you look at the formula bar, square root of J13. So the copying function will adjust for columns and line numbers. Of course, this is a nice small sample, and it doesn't take a long time to calculate the standard deviation the long way, but of course we do have a shortcut. So I'm going to use the function called STDEV for standard deviation P, and then brackets. Here we go. This is the standard deviation for a population. It does matter whether I have a population and a sample, and why we have a different way of calculating standard deviation. So we use our equal sign because it is a function. We use the abbreviation for the standard deviation of a population as STDEVP. Start the bracket. It wants some numbers. The numbers are your original data values, the amounts of money that were in their pockets. So I grab them with my mouse, close my bracket, and press enter. And notice I get the very same number. The standard deviation of a population is the same as the standard deviation that we calculated the long way. I'll just copy that formula, Control C, and paste it over here, Control V for data set B, for group B. And there you have it. This is how you calculate the standard deviation for data.
Now we have crunched the data for group A and come up with its standard deviation, 1.69. We did the same thing for group B, and its standard deviation was 2.20. Now we can make a comparison of how spread out the data is for each of the two groups. And we see that the smaller number in A shows the data is not as spread out as the data was in group B.
If necessary, make sure that you review this video.